Hello and welcome to D3D12Ez, a new video series here on the Lüttich Fussel channel. Now in this video series we're going to take a look at DirectX 12 in a easy way. Now if you are a long-term subscriber of this channel or you basically came to this channel through my normal DirectX 12 series, you already know that I have already done DirectX 12. However, this other DirectX 12 series was called the Advanced series, which went a bit more into the details on how you can do a bit of a more advanced architecture, how you can bring this all together and really get out all the nifty details of the API and what's possible with it, which is now from nowadays not even that relevant because many new things have been added to DirectX 12 that had not been taken care about on the traditional tutorial that I've done. So what I've decided is to do a new tutorial series on DirectX 12 to kind of like fresh this up with a bit of a newer modern approach on doing it. Now the approach that we are doing in this video series is a kind of like ad hoc easy approach. So the idea is that we are only going to discuss what is necessary. We don't want to go into all much too details. We don't want to write fancy classes that make things even more complicated to understand. We don't want to write some multi-threading stuff and making it all as performant as possible. No, that's all something that we don't want to do in this series. In this series we want to really do it the easy way, and we want to get into it, and we really want to just understand how a basic DirectX 12 application works. I'm going to try to explain as much as possible all of the concepts, all of the ideas on how we can go even further and make it even more powerful. However, we're going to try to implement it as simple as possible. And that's what we want to do, and we want to start in this video. Now, this is also good if you want to watch my real-time rendering series. My real-time rendering series is going to basically assume that you know DirectX 12. So yeah, for that, this video series is totally fine. Alright, so let's get started here. We want to directly dive in and take a look at the project settings. I already created a Visual Studio solution, and what I want to do is I want to quickly walk you through on what I have changed so that you basically can see what's going on here. Now, we just have a 64-bit configuration. We do not have 32-bit. That's everything that we need. We don't need all that 32-bit stuff, just a very basic 64-bit. Now you can see that I've changed the output into intermediate directories. This is just how I like to do it. If I go in here, you can see an example here. I'm basically putting this into, let me get the window onto the correct monitor. Here, into the build directory, subdirectory x64 minus debug, and then in the subdirectory bin for the binary, subdirectory obj, and the project name for the intermediates. Now, what I've also changed is I've changed the C++ version to be the latest one. Now, to use all of the DirectX 12 and DXGI features, so DirectX 12 is the graphics API for rendering, and DXGI is the support infrastructure that allows you to enumerate GPUs, find out which GPU is suited for which monitor, or basically which monitor is connected to which GPU, how to actually interact with the Microsoft operating system, so how to create kind of like the interface between actually showing what you are rendering on the screen, because this takes like the way of actually talking with the operating system. This is all handled by DXGI. And to use all of these features, you need a few linker dependencies. You can already see that they are in here. Let me get the full full window open and over here. We need these three libraries. We need D3D12.lib. D3D12.lib is DirectX 12. Then we need DXGI.lib. DXGI.lib is the basic library for all of the interoperability with the operating system, with the GPU, and all of that stuff before we are getting to rendering. And DXGUID.lib, these are all the GUIDs, so global unique identifiers that have been defined by Microsoft. Now, Microsoft has a very special approach of them. They are kind of like defined in the headers. However, to use the GUIDs, you need to have a library, and this library is required to access the DirectX GUIDs. This is why it's called DXGUID. So this is like DX12, DXGI, this is all included into the DXGUID.lib library. So these three libraries is everything that you need, and you can start off and go on. Now, I think I've also changed the include directory. So I added the project directory to the include directory path so that we can include everything that's in our project path. All right, so this is all the configuration that I have done in here. Now I have added a simple main file currently, and if I run that, of course, we're going to get an hello world, because that's the most trivial application that you can do. Let me get the window over here. There we go. There we have our hello world message. And yeah, that's basically what we got here. Now, what we need to do before we can actually get started and write some code for DirectX 12, we need to do and add a few support headers and understand a few features on how Windows works. Now, since we want to use DirectX 12, we also need to use the Win API. Win API is the API that's provided by Microsoft for Windows programming. Windows programming includes creating windows, so the actual window, like the Visual Studio window, all the windows like the console window, these are all like windows inside of Windows. I mean, yeah, it's a bit hard to say, but the name of Windows is named like Windows because it is composed out of Windows. So that's kind of like the idea here. All of these Windows stuff is in the Win API. All of the audio stuff is partially in the Win API. The Win API includes features for like finding out where the cursor is, making sure that the cursor is only in your game window if you're creating a game. There are many features in here, and if you are writing a graphics application for Windows, you need to use the Win API. Now, what I want to do is I want to now create a way on using the Win API, because normally if you would use the Win API, you would just include it, right? If you want to use Windows, the most easy way is just to include windows.h, and if you include windows.h, everything is good. However, the Windows header here, I could go into it, but I don't really want to go into it. We could open this up, go to the document. The thing is, the Win API header has many options that you can specify. You can see these are all preprocessor defines that you can actually define and basically parameterize on how you want to use the Windows header. So for example, if that one is defined, then all of this stuff is defined. There are many ways to actually customize the Windows header and how it is used. And there are actually a few things that basically even break on C++. So there's a thing, the min and max macro on Windows, and if you are using the min and max macro from the windows.h, then the std min and max will fail, because it's kind of like trying to go over the Windows macro instead of the std functions, and your code at some point is no longer compiling. And yeah, there's many things that you need to be concerned when using windows.h. Now, you can overdo it. I'm not going to overdo it. I'm just going to use the macros that I found out that I need to use to customize the Windows includes. But the thing is, right, we're going to include Windows many times, and always defining this macros is not a good way of doing it. So what I want to do is I want to create myself a subfolder. I want to call this one support. This is the support includes. The includes that have nothing to do with DirectX 12, that are just a bit of support structures around everything. And inside of that, I'm going to call this one win include.h. Now, it's not possible to call this windows.h because it might conflict, and I wouldn't recommend doing it. You should always try to keep your headers not conflicting with any other header. So calling it win include is a good way on not having any name conflicts. Now, again, in here, I want to include windows.h, and there we have it. And what I want to define is the macro no min max, and the macro no min max is basically telling Windows that it shall not use the Windows internal min and max macro. Now, normally these ones would be possible. If I would not define that one, these macros would turn out to actually work. Or not, but you can see that they are kind of like expanding to something. And if I added it back in here, these macros will not really go to anything. And that is something that needs to be there, right? This is the most important thing if you're including Windows. All right, I personally tend to abuse the Win include header for all of my Windows-related stuff. So DirectX is a Windows API, so what I also do is I'm going to include DirectX 12 inside of my Win include header. So for using DirectX 12, I want to include D3D12.h. Now we have DirectX 12 in here, and since we need DirectXGI, DXGI is also something that I want to use. There's a normal DXGI header, however, this is not recommended. It's always recommended to take the latest one, and in this case, the latest one is the DXGI 1_6.h. Now, both DirectX 12 and DXGI come with debug headers, a so-called debug layer. And what we also want to do is we want to use that debug layer. We want to use the debug layer so that we can have access to all of the debugging infrastructure that's provided by DXGI. So what I want to do is, if the debug macro is defined, I want to also include the debugging stuff and the DirectX 12 stuff. It's D3D12 SDK layers.h, D3D12 SDK layers. SDK stands for Software Development Kit, and these are the layers, the validation layers of DirectX 12. We have something similar for DXGI. However, it is called, for the DXGI, it's called DXGI debug. So this is what we want to include, SDK layers and DXGI debug. If I switch to release, they also automatically going to be cancelled out and going to be away, so that they are only there if we are in a debug build. Alright, so this is everything that we need for our Windows includes, and what we now can do is to use all of the Windows features. I can include support win include, and then I have all my Windows stuff in here. I could check this by, for example, get cursor, the get cursor function. No, actually, I don't think that I want to have the get cursor. I want to have the get cursor position function. This is a function that can actually return you where the cursor is positioned. I can put this in the point, and just for debugging that my Win API is correct, the cursor is then maybe I want to have some X position, PTX, and then some Y position, PTY, and then I get some information on where my cursor is, if I just want to quickly see that Win API is working. And that's something that we might also want to use in the future. And if I would take a look on here, you can see that I have some odd positions for the cursor. This is because I'm doing this on a different monitor. If I move it around, the position changes. If I move it there, yeah, the position changes as well, so it kind of like seems to actually fit. Just some oddness here so that I can show you that the Win API is actually working. Now, this is everything that we need for getting the normal Windows API stuff working. Now, what I want to talk about in this video is the concept of a ComPointer. Now, Microsoft uses something called the Com API, or also known as IUnknown. In general, Microsoft has provided this concept of programming for multiple reasons. They have defined this concept of programming for multiple reasons so that your code that you're writing in C++ or maybe even C# can be used across multiple programming languages, can be used across multiple compiler and compiler versions, and even if the ABI, so the application binary interface, is changing. So basically, if you have a virtual class with virtual functions in here, there is a certain rule on how the layout of the virtual table is located. There is also rules on how to call virtual functions, and there are many rules applied with that one certain compiler, how the one certain compiler interoperates with other software, and different compiler do it differently. And what Microsoft did is they defined something called ComRP, and basically ComRP is a decoupling between the certain ARBs and even certain programming languages. They basically provide one way of accessing and retrieving objects and instances of objects, and all calls go over an interface that is specific for the compiler that is then actually calling the Com API, which is then in a universal way calling the actual object, so that you can have multiple versions, multiple compilers, multiple programming languages all interacting with the same library. And basically what they have done is they have built DXGI and DirectX 12 on top of COM. It's actually a special version of COM. It's not a classical one that you could use. However, they have built it, DirectX 12 and DXGI, upon something called COM. And since we need to support COM, we actually need a way to handle these COM pointers. Now, a COM pointer in general, it is not that difficult. It's called IUnknown, the interface. It's a basic interface in C++. IUnknown, it's the interface. P, if I would call this one P, and basically what you have, if you have an IUnknown, you by default have three functions available. You have the function addref, query interface, and release. Release is a function that you're gonna call every time you're finished with a COM object, and if you're finished with a COM object, it's getting released. It maintains an internal ref count, and by calling release, the ref count is decremented, and if the ref count becomes 0, then the object is destroyed. There's also a function called addref, and addref is basically the different version of release. If you are calling addref, the ref count is incremented of the object, and release is kind of like decrementing it and destroying it on demand. They are kind of like returning a new long, an integer that indicates how high the ref count is. Now, each of these IUnknown pointers also have the query interface method. The query interface method allows you to cast the IUnknown object to a different object of your choice. So, for example, on DirectX 12, we're going to have an ID3D12 device later on. And basically, the ID3D12 device is built on top of IUnknown, or maybe not even on IUnknown, but the device is built on an ID3D12 object, and the ID3D12 object, if I would peek in here, is built on top of the IUnknown. Of course, it has a few more options here, like get private data, set name, and a few more things that are common on DirectX 12. However, in general, everything that we're going to deal with in DXGI and DirectX 12 is going to be an IUnknown, and IUnknown supports casting between different types of interfaces. And what you can do is you can now cast this basically to something else, or you can try to cast this by providing a device pointer. And if I do this like that, it tries to cast this. This is a templated version that is doing a few more things behind the scenes. Sometimes you're gonna see me using something called IID PPV arcs. IID PPV arcs is the old C style of doing it, and this is actually a style that we're gonna need later on. The IID PPV arcs is actually going to do two things. It's actually going to separate this one device argument into two arguments. It is separating this into a UUID and a pointer to a pointer. Now, the pointer to a pointer is basically the pointer to that device, so that if query interface succeeds, can set this pointer to a proper value, and the GUID, or in this case it's actually a UUID, that UUID is used for indicating which kind of object you want to try to get, because basically every interface is going to have a GUID. You can see that there's a macro MIDL interface, and then there is a UUID specified, and basically this is the UUID of the ID3D12 device. And with the IID PPV arcs helper, we are extracting the UUID as the first argument and the pointer to the device pointer as the second argument, so that the query interface can correctly set this all up and work with that all together. Now, working with these ComPointers is something that needs to be understood, and if you don't understand this, it is bad, because you need to make sure that reference count is always good. The general rule is if you are getting the pointer from a function call, it is already ref counted for you, so you never need to call add ref if you are getting an object from somewhere else. However, you always need to, of course, decrement your ref count, and if you internally save the pointer somewhere else, you, of course, should also call add ref, so that you internally use ref counting the correct way. So in general, like, IUnknown is a special version of a smart pointer, right? That is kind of like the idea. Now, handling these ComPointers is a bit cumbersome. So what we want to do is we want to make this a bit easier. Now, there are, of course, classes available by Microsoft that help you handling ComPointers. However, I don't like them. I have my own version of a ComPointer, and I know many people that have their own version, because most of the time people don't like the Microsoft one. This one is free to use. It is not requiring any license. It is up on GIST, on GitHub. I recently also even updated this to make it more performant. I update it from time to time. But what we're going to do basically is we're going to copy that ComPointer. We're going to go in here, ComPointer.h. And I am going to paste this in here, make this like that. And I think the Pragma wants is currently in here. So yeah, that's it. The ComPointer is already in here, and it is basically taking care of everything that you need to know. So in general, this ComPointer class that I have written, it is useful as similar as a normal pointer. It is not really destroying anything the normal pointer could do, but it's giving you a few more options that you get by using it. So if I would include my ComPointer class, ComPointer, I don't know why Visual Assist is recently a bit bitchy on my machine, but it is. Maybe I should reinstall it. And if you do that, you can basically create your own ComPointer, and it's gonna handle reference counting all on its own. And you basically, if you're using my ComPointer and if you're using it throughout the whole video series, throughout your whole project, you're basically never gonna need to worry about ref counting, about calling release. Everything is handled in here, but it does not prevent you on actually using functions like release. Of course, it's always important that you call the dot release and not the pointer release. That's important, because if you want to work with my ComPointer, call that one release, or the internal state gets corrupted. But what you can do is you can, of course, do the manual memory management like it would have been done previously. It also supports query interface in a smart way, which also makes this already a function that returns a Boolean value, and additionally allows you to provide the age result error code, or at least I think it should be it should be optional. Yeah, I don't know why Visual Assist didn't show this to me, but in general it provides a bit of a scaffolding around all these functions to make them a bit more useful, make them a bit more checking, and basically allow you to handle all of these features a bit more graceful. All right. So that is kind of like the idea of today's video. It was a bit of talking about what this video series is, how to set up all of our includes, how to set up ComPointers, what ComPointers are, and yeah, in the next video we're going to talk about the debug layer. Now the debug layer is a layer on DirectX 12 that helps you on the debugging mode. DirectX 12 is known for not working most of the time as soon as you get something ready. If I write some DirectX 12 code, most of the time there are 1 or 2 or 3 things wrong with it. Not wrong with like a syntactical side, but wrong with kind of like the usage. And yeah, most of the time it's hard to find these without the debug layer, and the debug layer is going to provide you some information on what happens. It's basically printing this in the output window down here in Visual Studio. It's basically telling you exactly what went wrong with your application and how you can fix it. All right, so that's it for today's video. I hope you enjoyed, and yeah, join me in the next time when it's again the time for D3D12Ez. Thank you for watching. See you. Bye.